If you are a data engineer working on a migration project, you might have to compare the output from your pipeline against the legacy pipeline. That essentially means the output tables from your pipeline will have to be compared against the output tables from the legacy pipeline. Now, generally, you compare the metadata of these two tables. That is, if all the columns are coming out, all the data types for those columns are correct or not. And then also you want to do some spot checks by comparing some sample rows to see if the values for these columns are coming out as expected or not. And then at the end, you want to compare row existence. That means if all the rows are coming out in your table, just like the legacy table. Now for a couple of tables, this is an easy job, but if you have to compare hundreds of tables, it becomes tedious and time consuming. Today, we are going to introduce a new tool called Tulona, which can automate this task for you. We are going to see how we can set up Tulona and how we can use it. Okay, setting up Tulona is just installing Tulona, the Python library, by executing this pip install command in your Python environment, and then we will move to the setup. I have created an entirely new Python environment. I'll just do pip install Tulona. This will install the library for me. While this installs, we will just look at how to set it up. Setting up Tulona basically means setting up the connection profiles. And by connection profiles, I mean the credentials and other details that you need to connect to the databases. Right now, Tulona supports 4 kinds of databases. As you see here, it supports Postgres, MySQL, Snowflake, and Microsoft SQL Server. And for this type of data sources or databases, we need to set up these parameters in the profiles.yaml file. But before that, let's look at where the profiles.yaml file has to be set up. This file has to exist under a directory called .tulona under the home directory. So go to your home directory, create a folder named .tulona, and under the directory, create a file called profiles.yaml. And it takes the extension YML, not YAML. In that profiles.yaml file, we will set up profiles like this. For this demo, we are using a Postgres database and a MySQL database running in Docker containers. And we will go to our code environment and set up the profile. Our Tulona library has been installed here, and we'll just confirm it by doing a pip list. Yeah, so it is installed 0.7.10. and that is the latest version. All right, now we will go to our home directory. Now we will create the folder called .tulona and create the profiles.yaml. But for this demo, I have already set it up, so we will just look at those. So the .tulona directory is here, and then the profiles.yml file. Now let's look at the profiles.yml file. The type parameter is mandatory here. That's how Tulona understands what kind of database it is interacting with. For this one, it is Postgres, and for MySQL, it is MySQL. You can find all these adapter names here. So if you're using a MySQL database, choose this as the type, or if you're using a Snowflake database, choose this as the type, and this is case sensitive. Okay, then we have to provide other details like database, username, host, port, etc. That's it, our profile is set up. Now we have to set up another YAML file that is called project YAML file. That is where we define all our data sources, as in the tables and other things that needs to be compared. Let's look at the project config here. To start, very simple. So it has a version key, then the name of the project. This name of the project has to match with the name of the project we have mentioned here at the beginning. So you can set up multiple project profile setup in the profiles.yaml file, and Tulona will find the corresponding credentials and details from this profiles.yaml by looking at the project name, as you mentioned here in the project file and the profiles.yaml file. Apart from that, there is config version, then the outdir. Outdir key is mandatory because that's how Tulona will know where to write the comparison reports. Then the definition of the data sources. So data sources can be defined in different ways. We will set up by defining 2 tables that need to be compared, and for each of these data sources, you see there is a name of this data source. These names have to be unique because this is actually a Python dictionary, the data source. So these are the keys of those dictionaries, and they themselves are also dictionaries. So in that dictionary, you have a connection profile. So the connection profile name or the value for that connection profile key has to match with this. In your profiles file, you have set many profiles under one project, and each profile is there for one database. Tulona will identify the connection profile to use with this data source by mapping the connection profile name from here to here. As you see for the MySQL table, it matches with MyDB here and here. All right. Now the other details, that is the database name, schema, and table, etc. etc. Then, since you'll be comparing rows and columns, the data from these two tables need to be joined. And that happens based on primary key or any unique key. So we have to mention the primary key here. For our table, it is employee ID. And then you might also exclude some columns from the reports. You can list them out here under the exclude columns key and the compare column. The primary key is used basically to compare some sample rows. For spot checks, and compare column will be used to check row existence. That is all the rows, but only the compare column will be compared to see if all the values, or rather all the rows, are present in both the data sets. If there are some mismatches, it will be reported in the comparison result. We will see how that works. Okay, our basic project.yaml file is set up. Now, you can set this up anywhere you want, but I would suggest you create an empty directory for your project, and then under the directory, you set up this Tulona project YAML file. Because when you run Tulona, it will generate a bunch of Excel files under a bunch of folders, and that will be created under this directory where the Tulona project.yaml file exists. Now we have to go to the project directory where this Tulona project.yaml file exists. Tulona is a command line tool, so we will use our terminal to execute all the commands. Now the first command should be Tulona, and then the name of the task that you want to execute. We want to execute a comparison task, so the name of the command is compare. And then we want to mention the data sources by the data sources parameter. So after specifying the data sources parameter, you have to provide the name of the data sources as comma separated values like this. Now, if you execute this, we will see the output. This is the log it will generate. You'll see in the console. But if you want to look at the debug level logs, go to the log folder and obviously look at the last log for the last execution, and you will see the log in much more details. For the output, there will be an output folder generated, and under that, the last run will be the result of your last execution. And there will be a run ID folder created under the output folder for each run, and corresponding other folders will be created, and then you'll find your comparison report. Let's look at the report. So going to our output folder, then the last execution run ID, and then this is the command we executed. So the name of the data sources, employee Postgres and employee MySQL, as you see here, without the underscores, and then the command we have executed. That's how the folders are named under the run IDs. Then if you look at the file, it is an Excel file, and this is how the report looks like for the comparison, or rather for the compare command. You see all the column names. So this is the output for profiling comparison or metadata comparison. As you see the tab, it will extract all the information about the columns from the databases for this table and compare against each other. Along with that, it will also calculate some of its own metrics like average, count, distinct count for that column, and then the min max values for that column as well. For employee ID, since this is an integer column, you will see an average, but for name, there is no average. So that is why you see NA not applicable. So all the numeric operations will be performed on the numeric columns, and all the other columns will have the value now for the metrics. But for the other info that was extracted from the database itself, you will see a comparison report. And if there is a mismatch, it will be highlighted like this. in yellow. Now, as you see, you can see many things here. If it's nullable in the employee MySQL, if it is nullable in employee Postgres. So all the columns from both of these tables will be presented side by side. For the numeric columns, you don't see a character length metadata, but you will see numeric precision. And if there is a difference, again, it will be highlighted. You see the mean values here for whatever column it is. Let's see which column. That's the age column. The mean values for the age column is different in MySQL and Postgres. That's why it is highlighted. That's how the metadata comparison or file comparison looks like. Now the row comparisons. This is for spot checks. Now in this, you don't want to compare all the rows because that will take up a lot of memory from your computer and it might crash your computer if you have billions and millions of records. And we don't need to practically do that, because if you do some spot checks for some sample rows, you will see the result. And there is also a column comparison to complete the whole comparison. We'll look at that later. Let's look at the row comparison first. So you see all the columns from both of these tables will be presented side by side for comparison. This is the employee ID. This is the primary key column that we have mentioned in our data source configuration. And that's why this column is presented at the beginning. Now all the other columns that are compared. You see the age of this employee is different. Employee number 2 is 40 and it's 11. So it might happen that the output in the Postgres is wrong. Again, the department is different, so that's why highlighted. And also we have specified the name column doesn't have to be compared. That's why you won't see that name column here. Now, by default, Tulona will try to compare 20 rows, but you can override that command by using sample count. If you say 50, it will create a report for 50 rows. Okay, we'll close this one and we will look at the last run. This is our last run. The sample count only affects the row comparison. We will see about 50 rows. Okay, so this way you can compare as many rows as you want. Now we will look at the column comparison. Column comparison is used to check row existence to see if all the rows are coming out as output in the table or not. Now what it will do under the hood is that it will compare the column you have mentioned here for compare column, and then it will generate a report. So for example, the row for employee ID 35 is not present in employee MySQL, it is present in Postgres. And this column will show you the presence of that record, and you'll have to understand the absence. As the employee ID 6, or rather the row for employee ID 6 is present in MySQL, that means it is not present in Postgres. So that's how it works. All the mismatches will be reported here, and only the mismatches. Tulona can do a lot of things, so stay tuned for more.